Today, we'll be handling a subtopic LCM of letters or algebraic LCM. It's taken from our page 63 of hidden fact in JSSCE mathematics. The same way we solved for the problems in numbers, LCM of numbers, the same approach we are using here. Let's take our first example. The LCM of 2a and 7a square is, first option, A, 14a, B, 14, C, 28a, D, 14a square, E, 28. Solution. We continue division till there is no remainder. LCM of 2a and 7a square. Let's impute our table and impute the values 2a, 7a square. Starting with the alphabet, because A can be used. When you apply A to 2a, when you divide 2a, you will be left with 2. And when you divide 7a square with A, the power of a square will reduce to 1. So we just write it as A there. So we have our value as 7a. A can still divide through. A divide 2 cannot, we'll bring it down. A divide 7a, we'll be left with 7. And we can proceed with the smallest prime factors in numbers. 2. 2 divide 2 give you 1. 2 divide 7 cannot, without a remainder cannot, so you bring it down, 7. Next, we proceed with 7. 7 divide 1, you just bring the 1 down. 7 divide 7 will give you 1. Conclusively, we can say LCM of 2a and 7a square is equals to a times 2 times 7. That is equals to 14a square. Another example. Find the LCM of 5ab square and 3a square b. Options. A, 15a cube b cube. B, 15a square b square. C, 15 square ab. D is 15ab. E, ab. Solution. LCM of 5ab square and 3a square b. We rule our line and impute the values 5ab square or 3a square b. Let's take the first letter there. A. A will divide ab square, 5ab square into left will be 5. Our result will be 5b square. A divide 3a square b. The a square will reduce to a raised to power 1. So we just leave it as a. So we have our result as 3ab. A can still divide through. A divide 5b square. Nothing will happen there. So we just bring down the 5b square. A divide 3ab. You will now be left with 3b. You can proceed with b. B divide 5b square. We now be left with 5b, because the square in power of b will reduce to ordinary b, and that of 3b will now be reduced to 3. We take b again. B divide 5b, you will be left with 5, and you just bring a 3 down. We are left with numbers alone now, so we can conveniently start with the smallest. And since the numbers that are left are prime factors, we take 3. 3 divide 5, you bring 5 down. You cannot divide it by a remainder. So 3 divide 3 will give you 1. We cannot take 5. 5 divide 5 will give you 1. And you just bring the other one down. Conclusively, we can say LCM is equals to A times B times B times 3 times 5, which is equals to 15a square b square. Let's take another example. The LCM of 9p square q and 15p q square is A. 45pq, B. 45p square q, C. 45pq square, D. 45p cube q square, E. 45p square q square. Solution. Let's rule our line and impute the given values. 9p square q, 15p q square. Now, we may choose to start from the numbers, prime factors. The lowest number that can go here is 3. You take 3. 3 divide 9, you'll be left with 3p square q. Then 3 divide 15p q square, you'll be left with 5p q square. We can still apply 3 again, since we are dealing with LCM. The 3 here with p square q will now be gone, and we'll be left with p square q. We just bring down 5p q square. Next, we take 5. We bring down the first resultant value p square q. Then 5 divide 5p q square, you will now be left with a p q square. You can see we are through with the numbers. Letters is now the next. Starting from p. P divide p square q, you will be left with p q. And p divide p q square, you will be left with q square. Next, we can still take p, since our values still have p. Once p divide p q, you will be left with q. So we just bring down our q square. We can conveniently move to q. Q divide q will give you 1. In the second value, q divide q square will give you q raised to power 1. But we are not showing the power of 1 there, so we'll just leave it as q. Next, we can still take q. Q divide 1, you break down the 1. Q divide q will now give you 1. LCM is equals to 3 times 3 times 5 times p times p times q times q, which is equals to 45p square q square. Another example. The LCM of 6a square b square, 24ab square and 40a square b square c square is, the options are given. A. 96a square b square c square. B. 144a square b square c square. C. 124a square b square c square. D. 120a square b square c square. E. 240a square b square c square. Solution. Dividing through till there is no remainder. We rule our lines and impute our values. First one, 6a square b square, 24ab square, 40a square b square c square. Starting with numbers, the prime factors here, if we look at the given values, we know that we can start with 2 conveniently. When you divide through the first value, you'll be left with 3a square b square. The focus here will now be with the numbers. So 6 divide 2 will give you 3. 24 divide by 2 will give you 12. So we have 12ab square. 40 divided by 2 will be giving you 20. So we have 20a square b square c square. We can still take 2 again. 2, the first set of values, just bring them down, since 2 cannot divide through. Now 12 is our focus here. 12 divided by 2 will give you 6. So we have 6ab square. 20 divided by 2 will give you 10. So I will now have 10a square b square c square. We can still take 2 again. We just bring down your first set of value, 3a square b square. 2 divide 6, which is in the second value, will now give you 3. 3a b square. 3, then 2 divide 10 will now give you 5. So we now have 5a square b square c square. The next smallest prime factor is 3. So we can divide through by 3. 3 divide our first value, the 3 there. We now 3 divided by 3, you have 1, but we're no longer showing the 1 since we have other values there. So we write a square b square. 3 divide 3 here too, we will now be left with a b square. We're not showing the 1 since there are other values included there. Now you just bring down the last item there, which is 5a square b square c square. Next, we can conveniently take 5 and stay dealing with numbers. 5 divide the first set of value, we now have a square b square. Then we have a b square. And the third set of value, 5 divide 5, that will give you 1. We're not showing the 1 because of the letters we have left. So we now have a square b square c square. We are through, if you observe very clearly, we are through with the numbers. So we can move to letters, starting from the first alphabet, A. A divide a square b square. The a square will reduce to power 1, a. So we just indicate it as a. So we have a b square. Then a b square will now reduce to b square. A square b square c square divided by a. The a square there will reduce to just a raised to power 1, but the 1 will not be shown. So we just have a b square c square. We can still divide through with a. Remember, we are dealing with LCM. So we are through with a particular letter. A divide a b square will now be left with b square. And in the second set of value, we just bring down our b square. Then a b square c square will now be left with b square c square. Next, we can proceed with b. B divide b square will now be left with b. And b divide the other b square will now be left with b. Because power 2 will reduce to power 1 in both cases. But we don't indicate the 1. So b square c square will now be left with b c square. We can still divide with b. B divide b will give you 1. B divide b again will give you 1. Now b divide b c square will be left with c square. From our resultant value, the next item to proceed with is c. C divide 1, you just bring down the 1 and you bring down the 1 in the second set of number. Then c square will now be reduced to c. The power 2 will reduce to 1. But we don't usually show the 1. So c dividing again, you bring down your 1 in the first set of value, second value, bring down the 1. Then c divide c will give you 1. We have achieved uniform 1, 1, 1. So we can conveniently say LCM is equals to 2 times 2 times 2 times 3 times 5 times A times A times B times B times C, which is equals to 8 times 15 times A square times B square times C square, which is equals to 120 A square B square C square.